With Tyler Ward, who's really kindly agreed to just tell me a little bit about what he's been doing on the project. He's part of the Eric the Rhino project and has been from the start. And so yeah, hi Tyler. How you doing? Can you just tell us about yourself first, actually, before we launch in?
I'm currently doing a PhD here in ECS, focusing on Internet of Things, so smart object, intelligent device type stuff. I'm currently working on stuff for the Rhino's eye systems and that, so controlling the webcam's orientation and other features on it.
Great. What made you get involved with the project initially?
It sounds like an interesting thing.
Yeah,
I get involved with fun projects that have interesting stuff. It sounds like a bit of fun, so I just had to get involved.
Yeah, it's good. So, what are you part of like a particular team with Eric the Rhino? Or are you on your own, or?
At the moment, I think I'm mostly on my own, just working on Mechatronics stuff at the moment. So I've started looking at that on the eyes and that, trying to get the eyes doing bits. Try and look at other bits like the ears and the other systems we need.
Great. So, can you just show us what you've got so far?
Yep.
What all this?
I've got two bits so far. This bit here is a test of orientating the eye, so it'll be able to look round things. It's attached the webcam to a servo, so when we feed it things, it'll be able to rotate round and look in different directions.
Oh wow! And that's just mounted by blue tack, is it there?
The blue tacks give a bit of extra support, but it's actually screwed down at the moment. The eventual thing is the fact that all the eye stuff will be properly bolted together.
Right. Okay.
Probably with the board taken outside of the frame of the webcam, because that ends up being a lot of bulk in the frame for such a small board.
So is this using a Raspberry Pi computer here to power?
Running off the Raspberry Pi, separate power supply for the servo. It uses a bit of software called Servo Blast, which allows you to directly drive the servo from the pins on the Pi, so it avoids complicated external circuitry.
Brilliant. And what's that blue unit you've got over there?
The other one I'm working on is these webcams have a set of LEDs around it. On the previous ones, they've got a little dial here which you turn to adjust the brightness.
Right, okay.
However, we can use this on the Rhino. However, turning a dial is obviously a bit difficult when it's inside thing. What I've done is I've cut off the bit where the dial was. This is what was inside, just a small resistor you adjust the value of. And instead I've connected to a digitally controllable resistor. But when I give it the right command, you can adjust the brightness of the LEDs by changing the digital resistor.
Right, okay, correct.
Which allows it to give it some eye motion, so we can give it effect to the eye. Because rather than having giving it eyelid that can give it eye animations and that, we can make things like blink and that by controlling the brightness of the LEDs itself. Is that coming out reasonably clear?
Oh well, yeah.
Like it is in front. Yeah, always think the same brightness from the side at the moment.
Sure, yeah. Do you want to get a front on that just so you can see the... So is it, at the moment it's on a timer, is it, to go to switch between brighter?
About 5 seconds it switches, it'll then ramp up the brightness to being bright or ramp it down to being dark at the moment.
Right, and we can have more control over that, so for blinking you said, and...
Yeah, we'll be able to get more control. At the moment it's a prototype, so we're using a rather simple digital resistor that just allows you to either go up or down in resistance.
Great, okay.
The ones we're going to be getting soon allow you to just choose what resistance you want it to be.
Oh, okay, so great, so you can choose the actual brightness.
Make a very quick thing, so we can make it flash bright.
Right,
like temporarily,
bright then off, yeah.
And then off, or do any kind of ramping up and down in any way we want. Whereas this is a simple thing, but it proves of concept until we can get the extra kit.
Yeah, that's great. And so how easy do you think this would be for someone at home to do, or a student that's sort of looking at studying ECS here?
It'd be reasonably simple to do. The most complicated bit is the wiring up of digital potentiometer to that, because most of the ones out there only come in circular packages, so they're not easy to plug into things for testing. So that was a little bit of soldering and that to do, but
yeah,
relatively easy to do stuff. Most of these plug-in bits, because all this stuff at the moment is just running off a breadboard here.
Wow, that's cool. So how is this? So what's the steps to happen between now and actually getting this fully functional into the Rhino? I mean, how's it actually going to fit inside the Rhino? And
the first step is we're waiting for the components now to properly do this thing, and knowing the size of the Rhino's eye.
Right, okay.
We're tending to find a thing to effectively fill the eyeball, but that needs to be the appropriate size of the Rhino. It's currently in there. Then using that as the outside, we'll make it so it fits the internal board inside, and that's the camera pokes out.
Right, okay.
With this frame, we'll then mount the frame on the servo, and the servo itself will be attached inside the Rhino chassis.
And that's what controls the orientation of the
everything
eye.
else on the eye will then be attached to a servo.
Great, okay.
And then be able to rotate round.
Brilliant. That's really great. Thank you so much for showing us that. It looks like you've made some really great progress. I'm looking forward to actually seeing it in the Rhino. Just on a final note, a bit of a silly question really. Is there anything in particular, if you could have anything on this Rhino, any feature, regardless of budget and whatever, getting the components for it, have you got any suggestions? What would you want to see on the Rhino?
So what I like to try and do is actually make the Rhino snort air out of the nose.
Right,
Which
okay.
is quite a complicated thing, because storing large amounts of compressed air is a difficult challenge in...
Okay. So, I mean, how would you do it? Would you have to do it with a balloon, or would you have some sort of pressurised cylinder, or...?
Looking at balloon that, because a lot of things generate instant compressed air, and it's a lot of noise, which is problematic.
Right, yeah.
So it's a case of creating some sort of storage system we can charge up without much noise,
Yeah,
and then
over
discharge
time.
them when we need the
Oh,
air
great.
to come out.
That does sound good. I don't know if we'll ever see that on the Rhino, but that sounds great. Well, thank you very much anyway for your time.
Thank you.
I appreciate that, and hopefully we'll see some more.